Okay, here we've got a complex number, which I'll label with the letter Z, equal to 5cis300. That's just a shortcut abbreviation for the cosine of 300 plus I sine of 300. And we want to find the fourth roots of that complex number using the nth root theorem. So in our case, n is equal to 4, and this is the formula. We take this number r, raise it to the 1 over n power, or 1 over 4, cis, and then we start with the 300, add on 360k, and divide that all by 4, and let k equal 0, 1, 2, 3. We stop at whatever n minus 1 is. So we're going to have 4 fourth roots of z. Now, if you put 0 in for k, you get 300 divided by 4 is 75. If you put 2 in for k, or 1 in for k, you get 300 plus 360 is 660 divided by 4 is 165. And you could keep going that way, but what you start to notice is that 4 goes into 375 times, and then 4 goes into 360k 90k times. So we're just going to keep adding 90 to 75, and then 90 to that result, and 90 to that result, and then 90 to that result. In other words, these complex roots are equally spaced around a circle with a radius of 5 to the 1/4, which is about 1.5. So this is 90 degrees. This is 90 degrees. 90 degrees, 90 degrees. And this number right here, for example, that's representing the complex number 5 to the 1/4 in polar coordinates, cis 75. And of course, this one is 5 to the 1/4, cis 165, and so on. Okay, there you go. By the way, if you use de Moivre's theorem to raise each of these to the 4th power, you'd end up back where you started. So you might want to check out de Moivre's theorem on how you take a complex number, like maybe we could call this W sub 1. How do you raise that to the 4th power? Well, you raise r to the 4th power, which would give you the 5, and you multiply this by 4, which would give you the 300. And you can do the same for the rest of these roots. There you go. Hope that helped. And if you have any questions, post a comment.